Today we're going to talk about functions. We'll start by defining a couple words. The first one is relation. A relation is a set of ordered pairs or some rule that we can determine ordered pairs from. This can include tables, mappings, graphs, equations, or even inequalities. Now a function is a special type of relation where every element in the domain maps to one and only one element in the range. In other words, every x value only gives you one y value. If one x value gave you more than one y value, it would not be a function. Let's take a look at some examples. Let's determine which one of these are functions and which ones are not. This first one is a mapping. It tells you that -2 corresponds to 4, 2 corresponds to 4, 4 corresponds to 16, 5 corresponds to 25, and 6 corresponds to 36. Each of the x values only corresponded to one y value. This is a function. Now I know what you're thinking. -2 went to 4 and 2 went to 4. Those x values gave you the same y. That is allowed. That is okay for it to be a function. It's okay for different x values to give you the same y. It's just not okay for one x value to give you two different or more y's. So let's look at this one. This one tells you that -1 maps to 3 and -1 maps to 4. This same x value gave you two different y values. It is not a function. Now let's talk about graphs. How do we determine if a graph is a function? You use what's called the vertical line test. If there's anywhere on the graph that you can draw a vertical line and it touches the graph more than once, it's not a function. If every and all vertical lines you could possibly draw only touch the graph once, then it is. So take a look at this graph. Drawing a bunch of vertical lines, they all touch the blue graph once. Now look closely. This ordered pair right here is 2, 4, and this one's -2, 4. We said this is a function because it passes the vertical line test, but two different x's gave you the same y. It is okay. Now this down here is called a step function. Notice this is an open circle and this is a closed circle. Open circle means does not include, closed circle means includes. So if we drew a vertical line through these, it would actually only touch the graph once. This is a function. Here's just a set of ordered pairs. There's just 4 ordered pairs. Draw a vertical line through all 4 of them. It only touches one point. That is a function. This last example is a circle. As you can see, the circle is not going to pass the vertical line test. Not a function. Now let's talk about equations. Equations are another way that you can determine ordered pairs, so equations make relations. How do we determine if an equation is a function? Well, you look at the exponent of y. One of 3 things is going to happen. The exponent is odd, in which case it is a function. It's even, in which case it's not a function. Or actually there is no y, and therefore it's not a function. So let's look at these following equations. Y equals 7x minus 3. This is a y equals mx plus b. It makes a nice slanted line. A slanted line will pass the vertical line test. It is a function. But also the exponent of y is 1. 1 is odd. It is a function. Y cubed minus 2x equals 2x squared plus 5. The exponent of y is 3. 3 is odd. This is a function. X equals 11. Here's where we don't have a y. And I told you that meant it's not a function. Why is that? X equals 11 means no matter what ordered pair you have, the x value is 11. So you could have 11, 3, 11, 2, 11, 1. When you figure it all together, it makes a vertical line. A vertical line is not going to pass the vertical line test, so therefore it's not a function. And this last one, y to the 4th plus 4x equals 2x cubed plus 6x squared minus 11. The exponent of y is 4. That's even, not a function. Now let's talk about our function notation. Generally, our equations are written in terms of 2 variables, x and y, where x is the independent variable and y is the dependent variable. You can solve that equation for y and have y equals something in terms of x. We're going to replace that y with our function notation, which is typically f of x. So no more y, we're going to call it f of x. Now f is the name of the function. The letter on the outside is the name of the function. If you have more than one function in the same group of equations or the same group of problems, then you want to give them different names. And inside the parentheses, typically x is your independent variable. That's the input that you're going to input into your function. Now to evaluate a function, you're going to replace the independent variable with whatever the input is, whatever's in the parentheses. So for example, here we have 2 different functions, f and g. F says you're going to take whatever the input is, 2 times that input squared minus 3 times that input plus 1. G, whatever the input is, takes 3 minus 5 times that input. So if I wanted to do f at 3, that means I'm inputting 3 for x. 2 times 3 squared minus 3 times 3 plus 1, and that gives me 10. G evaluated at 3 means I'm going to replace the x with 3. 3 minus 5 times 3 gives me negative 12. Now you can input all sorts of different things into functions. You can input numbers, positive and negative, fractions, decimals. You can also input other variables or algebraic expressions. So let's take a look. Same two functions, but now I want to do f evaluated at a, b, c. It doesn't matter, the process is the same. Whatever the input is what you replace all the x's with. I'm inputting the entire ABC, so I'm going to replace each of these x's with ABC. 2 times ABC squared minus 3 times ABC plus 1. Notice I don't have addition or subtraction in the parentheses here. I can distribute that exponent to get 2a squared b squared c squared minus 3ab c plus 1. No other like terms, we're done. Well, that seemed kind of silly, but that helps us introduce this next one. F of x plus h. I'm replacing x with this entire input x plus h. It's exactly the same as the last example, except a is x, b is a plus sign, and c is h. So, replacing x with x plus h, I get 2 times x plus h squared minus 3 times x plus h plus 1. Now the difference is I do have addition inside the parentheses. I cannot distribute the exponent. So I will have to do x plus h times x plus h. Also here, I'm going to go ahead and distribute that negative 3. Once I distribute the x to everybody and the h to everybody, I get 2 times the quantity x squared plus xh plus hx plus h squared. And then I still have a minus 3x, a minus 3h, and a plus 1. Now look closely. Are these like terms? I know they look different, x, h, and hx, but they have the same variables with the same exponents. They are like terms. You can switch this x and h. So we actually have 2xh. Now I'll go ahead and distribute the 2 to everybody in there. And I have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. No other like terms. We're done. Got some more definitions for you. I talked about this earlier. I'll bring it up again. The domain of a function is the set of all independent variables. This is the set of all inputs. This is what you're allowed to plug in. It's better known as the x values. The range is the set of all outputs. These are all the dependent variables. Once you stick all those x values in, the range is everything that comes out. Better known as the y values. Okay, so let's find the domain and the range of the following functions. So let's look at this parabola here. Notice it's going to get wider and wider and wider. The domain, every x value is accounted for. So the domain is all real numbers, negative infinity to positive infinity. The range, the smallest x value we have is 0, and then everything else goes up. So the range would be from 0 to infinity. This one, for the domain, we would just list the x values, negative 2, negative 1, 1, and 5. The range would be the outputs, 4, negative 3, 3, and negative 2. This last one, this circle, the domain, that's the x values it takes on. It takes on every x value from negative 5 up to 1. And the range is going to be all the y values. It takes on every y value from 1 to 5. So to write that in interval notation, domain, negative infinity to positive infinity for this one. Domain, if you just have x values or y values, you just list them in these brackets here, typically in numerical order. And the domain, closed brackets means includes. We did include 5. There is an ordered pair there, negative 5, sorry, and we do include 1. And then your range, you list it the same way. We do include 0 to infinity. Infinities always get parentheses because you can't catch infinity. Range will list as the y values, and this range would go from closed bracket negative 1 to closed bracket 5. We have 2 rules that we are not allowed to break in the real number system. Number 1, you are not allowed to divide by 0. That is an undefined value. The other one is that you can't take the even root of a negative number. More specifically, square root. That's the one that we typically deal with. So when you find the domain or of a function, you just need to make sure that we don't break one of those two rules. So for example, if we wanted to find the domain of 2x minus 6 over x squared minus 4x minus 5, we're not allowed to divide by 0. So this entire denominator is not allowed to be 0. So let's solve it. That means once we factor, x minus 5 times x plus 1 can't be equal to 0. So x minus 5 can't be 0. X plus 1 can't be 0. So that tells us our domain is every x value except for 5 and 1. To write that in interval notation, we would go from negative infinity to negative 1, not including. To connect intervals, we use a U for union. We'd go from negative 1 to 5, parentheses, union, 5 to infinity. To find the domain, this one has a square root. We're not allowed to take the square root of a negative number. So 3t minus 1 has to be bigger than or equal to 0. So 3t, we solve an inequality like you solve an equation. Get everything on one side of the equal sign, isolate the variable. Just remember, when solving an inequality, if you multiply or divide by a negative, you need to flip that inequality. Divide both sides by 3. 3 was positive, so we didn't have to flip it. So our domain is all values 1/3 and bigger, include 1/3, all the way up to infinity. That's it for this part of functions. I'll see you in the next video for more functions.